We're going to go over problem solving with exponents. So we've been given two containers. The containers have relatively similar measurements to them. The first container is called a cube. Okay? This cube means that every side is the same length. The width, the depth, and the height are all 9.2 centimeters. We've also been given a container that's a cylinder. The diameter of the circle on top is 9.2, and the height of the cylinder is 9.2, very similar to the cube. We want to figure out which one will have a greater volume to it. Okay? And the formulas for the volume of each of the containers are written below. They both involve exponents. So this stands for the volume of a CU, which means cube in this case. Okay? So the volume of a cube is S cubed, or to the power of 3. What does that mean, S cubed? What is S in expanded form, S cubed? What would that say? S times S times S. How do I find the volume of a cube? Length times width times height. Now they wrote it as just S because they're all the exact same. So I don't need an L, a W, and a H. Okay? They're all a side, so it's side times side times side. Okay? It's the exact same formula, they just simplified it for us. In a cylinder, they've given us pi, which represents a number that goes on continuously, multiplied by r, standing for the radius of the circle on top, squared, multiplied by the height of the object. Okay? So we're going to label each of these. S stands for the side. So essentially, it's all of these sides times each other. Now the height of the cylinder is 9.2. But what about the radius? What is the radius of the cylinder? That's right, we have to divide this by 2, because the diameter is the entire amount, but the radius is only half of that. So we take 9.2 and divide it by 2. Anyone know what we get? 4.6. So the radius here is 4.6. So we need to keep that in mind as we go through this. Okay, so let's go to the first volume, volume of a cube. The volume of the cube is equal to, we're going to replace S with 9.2 to the power of 3. We're going to use our calculator for this, so I'm going to type in these values, 9.2. And remember, this is our exponent button, to the power of 3 is equal to 778.688. So 778.688 centimeters what? Cubed, that's right. Volume is three-dimensional, and because it's three-dimensional, we put it to the power of 3, the measurement. So, the next thing we're going to do is the cylinder. The cylinder here, we're going to leave this symbol as pi, because I can type it in my calculator as the value of pi, and it'll give me the very large decimal that it is. The radius we're going to replace, so volume of a cylinder is equal to pi times, our radius is 4.6 squared, and the height in this one was 9.2. According to BEDMAS, what do we do first? We do that exponent for first. So, our 4.6 to the power of 2, okay, square. Oops, I went too far there. 1 sec, it gave me the answer already. 4.2 to the power of 2, 17.64. So 17.64 times 9.2 times pi. Now when we're multiplying, is there any specific order we have to multiply these things in? No, it's called associative property. We can multiply in any order that we like. So I'm just going to put the value of pi in here. Pi, okay, and see as it writes it as a number for me in my calculator, multiplied by 17.64 multiplied by 9.2 equals 2 decimal places is probably enough for us. So 509.84. 509.84. Yeah. Okay. So it looks like I typed this number wrong into the calculator. So let's correct that, which means it's going to change our answer in that. I typed it in as 4.2, you guys said. So 4.6 squared, yeah, is 21.16. 21.16, which is good. Let's do this again in our calculator. I'll go a little faster this time. Pi times 21.16 times 9.2. A little bigger. 611.58. So 611.58 centimeters cubed. Which one has a larger volume? The cube does. And let's make sense of this. Really, if the diameter is 9.6, that means that this circle, or this cylinder, would essentially fit in like that, and then have lines coming straight down. So we'd have all this area in here larger in the cube that we wouldn't have before. Okay, so keep that in mind. It makes sense intuitively that the cube would have a larger volume in this case. Oh, page width.